Hello, everyone, and welcome back to the Outcomes Rocket. I'm really excited to be here with Yossi Bar. He is the CEO and founder at LEM Surgical, just an incredible business leader, engineer, entrepreneur. He's been in the medical devices and robotics space in many different roles. He was one of the R&D leaders, the R&D leader behind the Mazorex platform, among other different accomplishments. I'm excited to have him here on the podcast. Yossi, welcome to the show.
I thank you for having me.
It's such a pleasure. I know you had a really great session at Device Talks. I know we missed each other there, so it's great to be together here on the podcast.
Same here.
So look, to kick things off, talk to me a little bit about you and why you do what you do and why robotics.
I'm in the area of medical device, more specifically surgical robotics, almost 20 years. I had a long military career and now the last 20 years medical device. Born and raised in Israel, and the last 5 years in Switzerland after I partnered with my Swiss partners, and that's why I'm here in Switzerland. I just stumbled into medical device, you can say. Again, long military career, and then at some point I said that, make love, not war. And less romantic than I just said it. And then I got an incredible opportunity to have a very small role in the young surgical robotic company in Israel. And I just got the opportunity. After many years, I told the guy that gave me the opportunity, I would not give myself the opportunity you gave me. But this is a different story. I just got a great opportunity and I just got to learn things from bottom up. And the thing that made it for me was the people. And again, having to be shoulder to shoulder with the spine surgeons, the people around them. These are incredible people. Everywhere they went, if you think about it, at some point from school to university practice, they were always the best of the best. So highly intelligent, very determined and hardworking. And I was hooked immediately.
Yeah.
And ever since, doing more stuff. At the end of the day, it's the people.
Yeah, it's really important. By the way, I spent 8 years in spine with different device companies, Medtronic, Stryker, NuVasive. So definitely I know how you feel. And when you're after excellence, it's great to be with excellent people. And before we started the podcast here, Yossi, we started getting into some of the nuances of robotics. I really loved the piece you wrote on LinkedIn, why a surgical robot is more than just a robotic arm and the transition from surgery 2.0 to 3.0. I'd love to unpack that here. We started talking about soft tissue versus bone and all of that. So kind of tell us what this piece is about and why you wrote it.
As we discussed, I told you that the reason that I'm writing this, not because I enjoy expressing myself this way, because it's a highly specialized area. And with today's people attention span, it's how do you convey a complex topic in relatively non-complex way. So this is why this, and specifically to this is, if you take a minute to break it down, the challenge that we have in what is called hard tissue robotics, spine, joint, we have a challenge that the soft tissue robotics, this is the known part. If you Google surgical robot, you will see immediately a Da Vinci. And this is what everybody knows. Without the history lesson 25, 30 years back, the way that it is constructed, and we will skip the why and how, they never encountered the challenge that we have, because from day one, from the get-go, the soft tissue robotics, the mindset was, it should be a remote manipulator. We need to mimic what the surgeon is doing because it's supposed to be a remote manipulator, a teleoperated device. So all the challenge that we have in hard tissue immediately were solved because, one second, if we mimic the surgeon, we need to operate in hands, naturally. We need vision, otherwise how the surgeon would see what they're doing. And then they added at some point a fourth arm, which is like a hand. There you go. They just solved all the problem that we have in hard tissue. Why? Because here you have two operating arms, right? You have a vision that is what we are regular as human beings. It's this triangulation. This is much more efficient than this. So there you go. The vision is in the center. Done. And maybe the most difficult part in robotics is the fact that the robot doesn't need to be accurate. The surgeon decides, there you go, I'm good. So the surgeon is the controller. In robotics language, the surgeon is the controller. The surgeon closed the loop. So you have two operating arms, you have vision in the center, and these are all the problems that we have in hard tissue. All the
Hmm.
robotics in hard tissue after more than 2 decades is one robotic arm that at some point we brought from the industry, the pick and place robot that was designed to do repeatable tasks and not surgery. The vision is not there, it's not close, it's far. And because of hard tissue, it's not a remote manipulator. So you need to solve all the problems of where you are and how you accurate, etc. So it's a completely different morphology. And that is why, while Intuitive and Da Vinci progressed as they progressed
Mm.
and gain more and more traction, hard tissue is like the slow brother. And this, what we're trying to do here in LEM is to change this, to say, once that is solved, let's go back enough with this, again, doing again and again the same thing. Let's bring a new platform to solve all this problem. To do complex tasks, you need two hands, but also the vision need to be much more sophisticated. And
Yeah.
this robot will need to actually complete tasks by itself. And then to all this, you inject the AI revolution. So now also this robot is much more intelligent. So you need a different form factor. And this is what we're trying to do here. I expanded from a question a little bit, but this is what we're trying to do here. We're bringing an upper torso humanoid architecture. I know today you say humanoid, people think of the Tesla robot. Only this is the wrong form factor for surgery. A quick example, when you saw a surgeon sewing a soft tissue, they don't use the fingers, they use needle drive.
Right.
So why? And the most difficult part in humanoid is the fingers and the hands. So why waste energy there? And there are more examples, many more examples. So yes, the humanoid architecture is fantastic. It's very capable, but it is with special form factors for surgery. And we believe that once you have this architecture ready, now hard tissue, the slow brother, can have this pivotal point and now be meaningful as the soft tissue robots are. Make sense?
Yeah, it makes a lot of sense. And there was a section, the analogy of capability, the carpenter and the neurosurgeon. I really like that. Like, can you unpack that one for us?
There is now a huge revolution in the world. Everybody talking about humanoid robots and billions are flowing to this direction. And I'm bullish on it. I think it's a good thing. But there is still this basic thing that the knowledgeable people will tell you, why do you really need a humanoid? It's a complicated thing. Better to build specialized machine, a dishwasher with a specialized machine, right? Build specialized machine. If you saw this video of Figure AI, when a humanoid robot is standing and sorting packages,
Yeah.
between you and me, a simple arm that does this would do the same job, or another specialized robot. And this is maybe the biggest scrutiny against the humanoid, that it's too much to do things. It's better to do simple, specialized devices, which is not the wrong thing to say. But there is a big thing behind the humanoid, which is the general purpose. Instead of we have multiple single purpose, simple devices, we should have, like we are, a general purpose thing. And for me, trying to break down how do we get to this architecture of the humanoid is that it has two main features that I think are important. One is the general purpose capability. If you think about it, how come the same guy can be a carpenter, orthopedic surgeon, a painter, or a basketball player? How is it possible, this general purpose? And then, at least for me, it was clear at some point, you said, because the architecture is the right architecture. It can do multiple things, but what changes between an orthopedic surgeon and a carpenter? These two things is the tools that they use and the training. So if you have the right robotic architecture, and this is, I think, the success of the Da Vinci, it's a general purpose soft tissue robot. So you're changing tools and training, AI, software, and all, no? But this is the key, to be general purpose. There is another thing that I discussed there, that maybe it's too much in the details, let me know. And then, but I
Let's
think,
get into it. I like this.
so besides the general purpose, we have another secret sauce,
Oh,
being
okay. Hmm.
that makes us so efficient in operating multiple tools, etc. And then it's an example that I use a lot because I think it's very common and easy to grasp. Imagine yourself hammering a nail to the wall. Naturally, you need your two hands. It's very
Yeah.
efficient that the vision is in the center and not somewhere like this, right? But when I tell you, yes, but when you hammer a nail to the wall, where are your gaze fixed? It's on the nail.
Yeah.
Decide for the first moment when you lift the hammer, you lift the hammer. By the way, your body immediately calibrates the situation. But from now on, you are looking at the nail. But when you
Yeah.
strike in some miraculous way, the hammer will find the nail. You don't look at the hammer. And there are multiple examples like this. You can open and close a bottle without looking in it. You can tie your shoelaces in the dark. And this is a very important. By the way, there is a word for it. It's a special word of proprioception, but some call it the sixth sense. Bottom line, your brain knows where your limbs are in space, and you can complete complex tasks. From time to time, you use your vision, but you're not fully dependent on the vision. And this allows you to do very complex tasks in a very efficient way. So it's not enough that you have the human structure, you also need this capability. And to the best of my knowledge, there is not even one surgical robot out there that has this capability. Again, not only to look like you, this you can build in a workshop tomorrow, but also have this capability, which bottom line is to operate multiple tools without looking at the hands.
Mm.
And this increases significantly the level of efficiency of the robot, which bottom line is come to the point that now this robot can do complex clinical tasks. So when I say humanoid robot, it's not just does it look like human or not, that it has this special capability.
Those capabilities.
Yeah.
And that's the difference, right? So if you are sitting at the scrub sink with the spine surgeon and you're about to go into the case, robot versus surgical humanoid, why does that matter? It's about these capabilities, right?
There, it becomes difficult that it's difficult to explain in few words. Because yeah. You look at the most sophisticated videos that NVIDIA, etc., or NVIDIA, Tesla, and figure out they release. You see this very expensive robot folding shirt. It's a very simple task that is easy to explain. You see, we fold shirts, we sort the groceries. Now go do the same thing with surgery and medical device. And this is the thing. Now, the real thing and what we do at the end of the day, what constitutes a good surgical or valuable surgical robot is not all the technological shenanigans you can do, which are important, naturally. What clinical value are you bringing? What clinical solution, what clinical problem you're solving, what clinical value you bring, and is it too expensive? There are fantastic clinical solutions that just are not affordable, right? So when you speak with a surgeon or when you, of course, when you design the system, the first thing that what clinical problem I'm solving and what clinical value do I bring? And you can follow the path through naturally the FDA clearances. So you have this technology, but what you're cleared to do. And this is what makes our life difficult, not what you can do technologically, what clinical application you are cleared to do. And this is maybe my biggest task or thing that I took to myself. Let's zoom out for a second again. Again, this human or general purpose. Let's take a minute. It's not just game of words or buzz or marketing buzzwords. Let's think about it for a second. Let's take, I think, very good example. Single purpose and general purpose.
Yep.
If I tell you maybe the most basic tool in the OR, scalpel. Amazing tool. Think about it. It's the best general purpose tool. How many things you can do with a scalpel?
So many.
The scalpel is not in the FDA clearance. I never looked for it, by the way. It will be interesting to see the first FDA clearance scalpel. But the scalpel is not clear to cut skin, to cut fascia, to cut. It's a general purpose tool. It's a fantastic tool. I think CT is the same. You can see it at a different level, but it's a general purpose tool. In a way, Da Vinci and all the rest, it's a general purpose soft tissue robot. It's not like the scalpel, but when you get, and this is the way it becomes tricky, when you get the clearance, It's not to do any soft tissue operation. You have
Right.
a FDA clearance to do this procedure.
Right.
And this is what makes things difficult because every time you need to get an FDA clearance for a specific clinical
Different
application that has clinical
application.
value. But I think the winning thing will be, and life will show if I'm right or not, if your architecture has the potential to be general purpose. Scalpel has a fantastic
Hmm.
architecture. It can be everything, or a CT device, or a Da Vinci robot. And I think, again, this is the key success of the Da Vinci. It's in the architecture, it's a general purpose soft tissue robot. And then every time the team's working on another clinical application. Let's solve this problem. Let's get a FDA clearance for this, but they can do it because the architecture allows. You don't find this in hard tissue robotics. In hard tissue, and again, we'll not do the history lesson. It is what it is. Hard tissue robotics, we also need to do naturally FDA clearance for this and this and this, but it is very difficult to expand. If you had a spine robot, it does spine. It's extra. It will not do shoulder. It will not do trauma,
Knees.
ankle and knee, whatever. And you will see, let's not say names, but very well-known companies that were fantastic 20 years in doing knee. They will really, really need to struggle to have very basic applications in spine, but they will never be a very good spine model.
Hmm.
Very difficult. Why? Because the architecture is very limited. And this is what we would like to change here, to have a general purpose architecture. And now you, every time, get another clearance. So this is, again, trying to connect why the general purpose architecture is important, while the real goal is to clear clinical application that has clinical value, have clinical value. This is the challenge and the balance that you need to bring.
Yeah, I love it. And, with that said, that's your vision for the platform you're building, right? To build
Yeah.
that general purpose hard tissue robot or surgical humanoid, right? Like
Yeah.
to take advantage of the opportunity to address clinical needs. You're about to say something.
No, fully agree with what you said. And again, it has more. And again, you need to say how much time and bandwidth we have. But fortunately and unfortunately, it's not a silver bullet because there's
Right.
no one problem to solve and there's no silver bullet here. Quickly, another key element besides everything we said until now, another challenge that we have in hard tissue that you don't really see in soft tissue. Hard tissue, you have hundreds, if not of thousands, of different instruments from dozens of vendors, hundreds of implants, different. So the surgical application that the robot is doing is always buying. There's an implant there. So and all the robots today that you had in the hard tissue, they're all buying to a specific implant, to a proprietary implant, and this is extremely limiting. So part of the general purpose capability of the robot, their, in my opinion, the right architecture, that you will have the basic capability to operate almost any tool. Imagine that I tell you, remember the hammer and the nail? Imagine that
Yeah.
I tell you, you can do this fantastic job, but only with one type of nail and one type of hammer that you need to learn in advance, and that's it. So what are you talking about? What kind of carpenter I will be? Or you can
Yeah.
use only one kind of screwdriver. This is the general purpose. A carpenter, imagine how many instruments this carpenter can operate, but imagine that he's limited only to a proprietary one brand. So this is also something that we do here, and our FDA, we have FDA for this. Of course, it has according to a clinical application. So now we're on spine, so in pedicle screws. But this basic ability, like you could use a hammer, take a tool that you never saw before. Because again, we have the challenge that our instruments, sometimes you see them only now when they're sterile in the middle of the surgery. Not always you can study them before the surgery. So here, this is the good architecture. Take a tool that you see now in the OR, sterile for the first time, like you do with a hammer. Calibrate it, study it, operate it. And now you have a real general purpose robot. So this is also another thing, the tools and the training, and you need an architecture that support this.
That's really great. I love the framework that you've laid out for this category and the approach specifically in hard tissue. I guess here, coming to the end of our discussion, and we might have to do a part 2 on this, Yossi, because I feel like we're scratching the surface.
Is it a threat or a promise?
It's a promise. I guess if you had one thing on your wish list as this category continues to unfold, what would it be and how would you shape it in a call to action for health system executives, surgeons to understand?
Hmm. Call to action to, and here it again, we have many customers. The surgeon is a customer, the hospital is a customer, the insurance company is a customer. Where would you like to focus?
You tell me. We could go up.
Okay.
You could tell me if you want to say something to each of them, if you want to focus on one, all good. And the CTA could be, hey, this is something like a frame, a perspective. It could be this needs to be done.
Very good.
I'll leave it to you.
100%. I'll say the following. And this, to be honest, a bit surprised me when I returned to this 5 years ago to try and bring the next generation. I was a bit surprised from the, let's call it, the low spirits that I found in the area. You know, this thing that happened the last few years, few big companies divested out spine, orthopedics.
Yeah.
It's not sexy anymore. All the
Yeah.
obviously just go to soft tissue, cardiology, etc. Say, okay, and by the way, I don't blame them. If you see what innovation we had in the last 10 years in hard tissue, you go to this convention year after year, same implants, different colors. So, okay, probably you have picked your capability to innovate.
Yeah.
And so let's say the call for action, or what you say, that I think that we didn't even start innovating there. The potential is huge. First, it's a huge market from financial perspective. It's a huge market, a lot smaller than soft tissue. That's what we're doing here. We're doubling down on robotics. Many companies, including the biggest one, they maxed out. They say, okay, the robot is doing this, and now let's optimize it now, make it smaller, make it cheaper, but this stuff, because that's it, it maxed out. And we say, on the contrary, didn't even start. So we need to push, double click on robotics, and now robotics needs to do much more. Instead of optimizing it, make it smaller and cheaper, let's bring more clinical value. And this is, as I say, let's double down on robotics. We just started with a huge revolution of AI and AI that is coming with very strong. I'm really proud of our small partnership with NVIDIA. They are investing there a lot in physical AI. It's a brave new world. We can do things today that 10 years ago we could only imagine. So the best part is yet to come.
I love that, Yossi. A lot of times when the crowd goes one way, you got to go the other way because there's opportunities there. And you're doing just that, Yossi, you and the team at LEM Surgical. I'm excited to see what you guys come up with. There's a huge opportunity here. So just thank you for joining us. And for everybody listening, I'll link up the article that we had our discussion about. It's a phenomenal read. Make sure you check that out. Yossi, if anybody wants to check out LEM, how can they get in touch with you guys?
Again, we keep it simple. So first, the website, there's a lot of information in the website, and I am personally very accessible through LinkedIn, just because, not saying it's the best platform, it's just a platform, very convenient. So a lot of information there. You can reach me out directly through there, and we'll be happy.
Fantastic. Well, thank you for that, Yossi, and thanks for being with us today. Looking forward to staying in touch.
Thank you very much for the opportunity. See you soon.